Designing and building a spacecraft in one semester is a challenge, but a group of University of Arizona students pulled it off with flying colors. Channel 6 science reporter Pam White has our report.
Like this, which are currently exploring Mars, are instrumental in better understanding what's out there.
So for quite some time to come, rovers will be the main way of exploring planets.
But how do you build one? U of A aerospace and mechanical engineering students didn't have much time to find out.
The challenging part about this course was that in just one semester we had to learn everything there was about spacecraft design and to also design a spacecraft.
The spacecraft design course was taught by Professor Kumar Ramohalli, who's designed many new technology for NASA's space program.
The rover that they have built uses some very innovative technologies compared to the previous rovers.
It was pretty difficult because you had to choose a certain landing site.
And then it got really difficult when we started getting in depth with things.
The class of 9 students chose to build a rover with its own small orbiter to communicate data back to Earth. While the team didn't have a lot of resources to actually build the spacecraft, they had to write a very detailed paper on how everything worked. Daniel Studer was in charge of the orbiter power and control system.
It's not like somebody can just break out and do their piece and come back and compile it all together. It's really an iterative process where you really have to all do it together.
So they all have to work as a team from day one, and that's one thing that they have demonstrated, and that's what they have to do in this business.
Something else about the business, knowing when to stick to the old or try the new.
The problem with spacecraft is that it takes several years to build and many more to launch, and you cannot keep on changing the design as you go along. So what we call the freeze of design occurs several years before the launch. Will we have technology that's so good and reliable by the time we launch it that we can bank on it? Or shall we go back to the old-fashioned, well-proven technology?
Senior Casey Liu says they analyzed a lot of case studies of past missions to see why they succeeded or why they failed.
For Mars missions, every single mission has used the same thing over and over again. That's because of the reliability of it. When you're dealing with such an expensive mission and such a critical part, you don't want to really go ahead and do something so high-tech that it has a chance of failure. Since this is such a critical part of the mission, you want to make sure your reliability is very high.
They incorporated the modern technologies exactly where they should have, and used old-fashioned, well-proven technologies where they should have. It was the perfect combination or balance between the old and the new.
Student Ian Phillips tells us why the rover they designed is different from existing ones.
It's different because the ones that are up there now are using solar power, and we're actually using a nuclear-powered rover. The nuclear power gives a lot longer duration and will also let us do a multitude of things. When solar, you have to, charge your batteries and only work during the daytime.
Professor Ramohalli says the class always has exceptional students, but this semester's team got rave reviews from some of the industry's experts.
Dr. Peter Smith, the PI of the Phoenix mission, upcoming Phoenix mission, he was kind enough to come. And when we had asked him to evaluate, he was so impressed that he did not fill out the forms assigning anything at all. He simply said, "Great work," which I think is one of the best compliments any student can ever receive.
He really drilled us. I mean, he asked so many specific questions, and what are you going to do here, and how did you do this? And we responded as best we could, but I mean, he asked some really pointed questions. It was really nerve-wracking.
Most of these students plan to have a career in aerospace engineering, and this course has given them a greater appreciation of what's involved in space exploration.
And what we learned is actually the level of analysis is incredibly high. There's so much detail and redundancy done to verify the results. It's amazing. And to be honest, like our team of just 9 people can't really touch what a true design team of hundreds of seasoned engineers can accomplish. But we were able to really grasp the difficulty of the situation. It really drives our learning experience, so we really have a great desire to learn more about space design.
For KUAT, I'm Pam White.
KUAZ Radio, news from A to Z. Tune in daily for award-winning national news coverage.